Hello, we're going to go over the skill check. So we're looking at creating a contingency table. So we're going to look at employed 40 to 45-year-olds in Santa Clara and Alameda County. Um, and we're going to create a contingency table that examines if work class is associated with sex. So let's first do our filter. We want to filter employment status to be employed, and we want to filter 40 to 45-year-olds. Okay. So I have my filter. I have 40 to 45-year-olds and employed. Always check, make sure it's filtered. And now we want to make the analysis. We want to analyze is work class associated with sex. Now the way I will always phrase these is work class is always the response and sex is always the explanatory. When I say work class is associated with sex, we're wondering, do males and females have different percentage of different work classes? So, not sure if you've ever seen the variable work class, but when you're looking at the variable work class, it basically is saying, are they government? Are they privately employed? Are they self-employed? Are they working for family without pay? This sample is 40 to 45-year-olds employed. Now, if I want to get a breakdown of how many women, what percent of women work in the government, what percent of women work private, what percent of women work self-employed, I need to go to the contingency table format. And then I need to type in women, I got to type in sex as the row. The explanatory variable will always go in the row, and the column will be your work class. Now actually, like defining which one is row and column, I mean, you could flip these around, but then, see, let me just show you what goes on. So when I click this, what I get is I get females and males. We got 1386 males, we got 1159 females. But it's hard to really make sense of this unless we can calculate the percentages. We would like to know what percent of females work for the government, what percent of males work for the government, what percent of females work privately, what percent of males work privately. So we want to calculate the percentages. We call this calculating it across the row because we want to know percent of women in government. So we're going to do 201 divided by 1159, 847 divided by 1159, and so forth. Okay? So what we do is we call that the row percent. So explanatory variable in the row percent. And what you get here, if we can see this all right, we have women. Surprisingly, women are 17% of women work for the government, while only 8% of men work for the government. A government might wonder what this is. This is like your police force. This is your, all the city and state, like government and services that are done through the government. Anyone who works for a school district is considered working for the government. Your private companies are companies like McDonald's or Tesla or Google or Apple. Those are all privately companies, and self-employed, work for yourself. So when we look at this, we see that there are pretty big differences in the government, working for the government. We see a 10% difference here for private, self-employed, not that much, working for family without pay, not that much either. But these are pretty big differences. A 10% difference in these two categories is rather large. So we would say this is an association. Now, I was saying you don't have to do it this way. I could have done work class here, and I could have done sex here, but then I would have had to calculate my percentages differently because now females are here and males are here, so I would do what we call column percentages. And it's still the same number. It's 17% of females work for the government, 8% of males. Now how you know this is calculated across the column is because you get a 1 here. That means all these percentages add up to 100%. All these percentages add up to 100%. So that's one of the biggest challenges is understanding, like, what am I seeing on this table? Notice we're never hitting relative frequency on a contingency table. We want to calculate our percentages either down the column or across the row. Now be careful, like if you, for instance, did this backwards, you did sex here and you did work class here, and then say you just did relative frequencies, just to show you what this looks like, it really is hard to make sense because it's not 7.9% of females work for the government. These numbers are actually the percent of the whole. So this is of all the workers, of males and females, 7.9% of them are female that work for the government. 45% are male that work for the private industry. You really can't make too much sense of these numbers here. Never do that. Instead, do row percent. Now, if we did column percent by accident, I want to show you what shows up here now. Now, when we look at this, the issue here is this percent says of those who work in the government, 64.6% of them are females and 35.4% are males. 42% of those who work for private industry, 42% are female and 58% are male. These add up to 100%. So we're calculating the percentages across the column. The concern with this is, the issue with this is you don't have same sample sizes. So to calculate it across the column doesn't really make sense, really. What you want to do is go across the row. Now, this is a complicated matter, but you should the question always should be like, what percent of females work for the government? What percent of males work for the government? What percent of males work privately? What percent of females? So it's like we're looking at females independently, and we're calculating the percent of females that are self-employed, the percent of females that are privately employed, the percent of females that are governmentally employed. That's the way we run it, because then you can compare the percentages. 17.3% for women versus only 7.9% for males. Hope that makes sense here.